Hello, my name is Ben Bevins, and today I'll be discussing additive manufacturing. I work in a lab here at the university working with additive manufacturing, so this is a subject that's very interesting to me. Today I'll be discussing what additive manufacturing is, how it works, and its possible uses in industry today. So first of all, what is additive manufacturing? It's the process of creating a part by adding material to the part, in contrast to traditional methods of manufacturing, which takes away material from the part in order to create the part. And the important thing to know about 3D printing is that 3D printing is additive manufacturing. So if you know the term 3D printing and you know what that is, you already know what additive manufacturing is. So how does additive manufacturing work? The first thing to know is that there's two varieties of additive manufacturing. There is plastic additive manufacturing and metal additive manufacturing. Now, due to the complexity of both, I'll only be discussing plastic additive manufacturing today. However, both work in the same way, by adding one layer on top of another layer. So you have your first layer that is adhered to some form of platform. Then you lay your second layer, which is then fused to the first. Then you lay a third that is fused to the second, a fourth that is fused to the third, a fifth that's fused to the fourth, so on and so forth until you've created your part. Now, to give you an idea of how many layers a part has, is the smallest parts that are created usually have about 50 layers. So these are very small layers in order to create a quality part. So how plastic additive manufacturing works is that it uses something called an extruder head. Now, this extruder head is what makes plastic additive manufacturing special and unique. So what it is that we have this plastic rod called filament being forced through this heating chamber in order to create molten plastic. Then this molten plastic is shoved through this nozzle onto the layer. So this molten plastic then is moved around onto the platform in order to create a layer. So as this part is as plastic is being spewed from the nozzle, this entire extruder head is being moved around the layer in order to fill the entire layer with plastic. Then it moves to the third layer, the fourth layer, the fifth layer, just filling all the layers with plastic from this part. Now, if all this sounds complicated and you're not quite grasping it, there's an example on the next slide that I'll be discussing. But the important thing to note about this type of additive manufacturing is that there's 0% waste. In contrast to traditional methods, which, as I was discussing earlier, takes away material, this only adds material. So therefore, there is 0% waste when done correctly. So the example I was discussing earlier is using a hot glue gun. A hot glue gun is exactly the same thing as the extruder. You have your hot glue stick being pushed through a heated chamber and out a nozzle in order to lay the glue. The only difference is that the hot glue gun lays one blob of glue in order to adhere two parts, and the extruder head moves around to fill an entire layer with plastic in order to create the layer. Then it moves on to the next layer and the next. So the possible uses for additive manufacturing are numerous. The first being rapid prototyping. Now, engineers, when they design a part, don't know if the part will be quality or if it's going to work the way they want it to. So before they mass produce the part, they can use additive manufacturing to create the part, make sure that the tolerances are correct, make sure the gears mesh, make sure everything is good to go before mass producing the part. Then another use is specialty parts. So if you are creating something that you only need one or two parts for, then you don't want to go through the entire assembly line. You want to be able to create the parts you need there and then. And additive manufacturing can create the part now and with less waste, which brings me to the third one, reduced waste. Additive manufacturing for both metal and plastic produce next to 0% waste, in contrast to traditional methods of CNC machines and lathes, which takes away material and creates up to 60 to 80% waste in the part. Today I discussed what additive manufacturing is, how it works, and its possible uses. Thank you.